Thank you, everybody, for joining. My name is Tim. So I work. My day job is at Akamai, where I consult our customers' websites to be as fast as possible. Next to my day job, I also run scalemates.com, which is the largest scale modeling website in the world. And I'm not here to talk about my work. I'm not here to talk about my scale model hobby, which you can see actually a few models in the back. I'm here to talk about responsive RUM. In my day job, but also when my wife falls asleep in front of the television and I'm fine-tuning the website, I love digging into real user monitoring data. Why do I like real user monitoring? Because it gives me really insights how my website behaves under real world conditions. Doesn't matter if a user is sitting on the train or in the sofa with their tablets, I can really look at how the website behaves under real user conditions. Now, although I love real user monitoring, my love is actually not endless. And the reason it is not endless is because it's not responsive. And that's a bit strange statement, right? It's 2021, responsive web design is certainly not new. All the RUM tools on the market support Core Web Vitals from Google. Many of them support PWAs or single page apps with soft navigations, hard navigations. Some of them even support measuring service worker startup times. So on one hand, all the tools, open source like Boomerang or any other available on the market, are modern RUM, and still I'm here sitting today saying RUM is not responsive. And the closest we can get to responsive design is this very simple desktop, tablet, mobile classification. And this very simplistic classification might have worked 10 years ago when devices looked like this. But today, where a big phone can be larger than a small tablet, or where a large tablet can be actually larger than a small laptop. And then my screen and maybe one of your screens might even look like this. So there is like a variety of devices, and the simple classification no longer works. So the point of my talk is, in a responsive world, like we are today, we need responsive RUM. So what I'll do next is I'll look at a few tips and techniques you can apply on your RUM. Doesn't matter which one you use, and how you can make your RUM responsive. So we need responsive RUM. Now, the first thing we need to fix, and that's like a prerequisite, is a bias. And which bias? The device type bias. Now, this is like a prerequisite for responsive RUM. And what do I mean with that is, if you're looking at this very simplistic classification, this is now from my website, 48% mobile, 46% desktop, 6% tablet. Every tool can do this. Now, when we talk in the performance industry about mobile performance, when I ask Sergey, hey, how is the mobile performance of Etsy? Or Sergey asks me, hey, Tim, how is the desktop performance on scalemates.com? Then in our minds, at least I make the link mobile equals cellular and desktop equals broadband and tablet equals Wi-Fi. Now, I know everybody knows this is not entirely true, but still in our day-to-day discussions, when we talk about mobile performance, we have that mindset, oh, that's mobile is cellular, desktop is broadband. And this is everywhere in blog posts, but also in super cool tools like Google PageSpeed Insights. You have a mobile and a desktop classification. What is mobile? If you read the manual, it's a mid-range device on a cellular connection. While if we talk here about what is the desktop performance, it's a high-end device on a good broadband connection. So this is everywhere. Now, is this a problem? And I would say yes, especially for RUM, because this is now again from my website, is what you see here is we're just looking at mobile devices and we're looking at the connection type. Now, suppose you're looking at the median. The median, 50% of your traffic of the performance is faster than that value, but it also means 50% is higher, slower. Now, if you look here at this, 67% of the users is actually connected on cable. What does that mean? Like now I'm at home, connected to the Wi-Fi. I'm in the end using a cable connection to talk to the web server. Now, what does this mean? Suppose you're looking at your RUM data and you say, like, I don't have a performance problem on mobile. Everything looks fine. Why is that? Because the median is the fastest 50% for my website. That's actually cable it's a phone on a cable connection. So while we think, oh, this is a phone on a cellular connection, in this case, it's not true. Same for desktop. There, 15%, that's a lot. 15% of my users uses a cellular connection while using a laptop or desktop. What can that be? In better times, when I traveled to London, I was working on my laptop and I was connected to the 4G connection of my cellular phone. Some of my customers, they're worldwide. On ScaleMates, they live in the middle of nowhere, and the only way to get on the internet is a cellular modem phone, which is like just a cellular phone stick on the wall, roughly, using a cellular connection. Also here, I and many of my customers, they look, for example, at the 90th or the 95th percentile, and then you wonder, why is desktop so slow? Like, it should be fast. When I test it on my computer, it's super fast. Why is it so slow? Because you're not looking at a desktop connection on a cable connection. You're likely looking at a cellular connection in that case. So first key takeaway is, even if you don't like the next part of my talk, is whenever you look in RUM data, make sure to add the connection type on top of the very simplistic device classification. So, making RUM responsive. The first thing is desktop, mobile, tablet. What does that tell you about the screen quality? Nothing. And why does it matter? In 2011, 10 years ago, a pixel was a pixel. Very easy. It was an easy world. Today, we have retina screens. We have high resolution images. And on my MacBook, I'm looking at now, a pixel is actually 4 pixels. And on my phone, not to brag, that's actually 3 pixels. And you even have phones with 4x. What does it mean from a quality perspective? From a quality perspective, it means that you need to ship an image which is twice the size width, twice the size height, meaning you ship 4 times more pixels in order to get better visual quality. Now, what does it mean?
Question. Sorry about that. Quick question in the chat, actually, about network connections before we jump more into this. How do you determine network connection? Is it based on Network Information API?
Yeah, there are a few ways, and I guess it depends on the tool. In my case, it's based on the IP info. I use the Akamai RUM tool, MPulse. So there it's based, we know which IPs are coming from a cellular network, which IPs come from a broadband network. So that's the classification based on the ISP. On top of that, I also use a networking API, which is correct, which gives me 2G, 3G, 4G. And what I don't like about the networking API, you get 4G also on a desktop connection because it's just based on the traffic pattern. So I actually use both. Does it answer the question?
Yeah, that should be good. But yeah, generally, all the information you get is not necessarily precise. So you can get only as precise as you can get, as the tool gives you.
Yes,
so
yes,
that's
correct.
probably worth saying.
Correct, yes. There is always a variation or a possibility that it is wrong. On the other hand, if you're typically with RUM, you're collecting a lot of data, even if here and there is a small percentage which is wrong, it should not really, in my view, impact your numbers. Perfect. So if there are any additional questions, now, and I can actually now switch to, I saw, no, now it's gone again, damn. I saw the chat window. Now it's gone again.
Yeah,
So
Greg comments in the chat that there are databases that provide the information similar to this AP information you were talking about, and also MaxMind is one.
yes, yes, correct. So we were looking at responsive images very quickly. What does it mean? I have 500,000 product pages, and this is an example of a thumbnail which is 160 pixels width and 96 pixels high. What do I need to do in order to show a good resolution image on a phone or a Retina screen? I need to provide the 1.5x and the 2x. So what does it mean? If on the Retina screen, I ship the 2x version, and here you can see, so the 160 version is around 6 kilobytes, the 1.5x version is around 11 kilobytes, and this goes to 24 kilobytes. Who cares, Tim? What is the difference from a performance perspective? Now, suppose you have a search with 50 thumbnails, not that uncommon, and you do 50 times 6 kilobytes, that's 300, or you do 50 times 22.5, that's a bit more than a megabyte. Does that matter? 300 kilobytes versus 1 megabyte for a mobile device on a cellular connection? Maybe it does. So in order to understand the performance, we actually need to know how much bytes do we ship to the different devices. And the good news is you can just extract that data using JavaScript. So if you type in JavaScript in the console a window.device pixel ratio, you get the device pixel ratio. And what do? I take that value and I send it to my RUM. But I also send it to my Google Analytics because I just need that data. So these are the different values you get. 1x, 2x, 3x, but also stranger values like 2.625. That's actually a very popular Samsung phone. And here, even 4x and 3.5x. Now, what if we zoom in on mobile? There are two things you spot. Actually, the first thing is, what don't you spot? Look at it closely. There is no 1x in my top 10. So today, this is for my website, might be different for your website, but high level, 1x mobile phones, almost not there. Other thing you see is you see the strange value 2.549999. Is that a bug in my code? No, that's just depending on the device. If I change the resolution on my screen, I change from 2x to 2.2x or 1.8 and a whole lot of other strings behind. So that's the amount of values. So as you can see, there are a huge amount of values. And that's actually my first idea was I just captured that. I just had too many different variants in order to make a good analysis. So how can we fix that? How can we fix this cardinality problem? It's actually easy. In the end, you don't care about the exact device pixel ratio. You care about the image you ship to the end user. And on my website, I have the 1x version, the 1.5x version, and the 3x version. So to a 4x device, I ship the 2x version. To the 3.75 pixels version, I ship the 2x version. So what do? In my data layer, I check, is the window device pixel ratio bigger than 1.75? Then the browser will pick the 2x. 3x, 4x, 2.5x, 2.888, blah, blah, blah. Always the 2x version. If it's bigger than 1.25, and between these two values, it will pick the 1.5x, and all the rest picks the 1x version. So what does it bring? Here you see like way too many values. And this is a simplified version. So actually, my homepage or my search page has basically 3 variants. It's the 1x version, the 1.5x version, and the 2x version. The exact device pixel ratio, I couldn't care less. And this gives me the option to zoom in. And now, for example, if I zoom in on the 2x version, I get 43% of all my data samples corresponds to that. While if I would pick it in here, I would just look at 21% of all the data set. And in RUM, the more data you have, typically the flatter or the easier it is to consume your data. So that fixes the, sorry. Next, what if you then zoom in on, this was for everything. If we zoom in again on mobile, this allowed me to do the following. I didn't do it yet, but I will do it very soon. What do you see? 1x for mobile devices is 0.19%, neglectable. So what will this allow me to do? Basically, it tells me the high, before I had a 360 pixels version image. Why? Because that's like the full screen image on mobile device. And I have 500,000 times a 360 pixels version on my server. Why? Because potentially 0.19% of my users grabs it. So what I will actually do now is, I think it will actually be faster to serve the 1.5x version to 1x devices. Why? Because the chance that they're in the cache of the CDN is much, much bigger. The chance, if you only have 0.19% of your users requesting content, the probability that this is in cache is actually very small. So I will ditch the 1x version. I will save a lot of space on my server. On top of that, yes, I will ship more bytes to my end users for those 0.19%, but the performance might actually be better. So that was screen quality. Screen quality is one thing. The other thing is screen dimensions. Large laptops, small tablets, big tablets, too many things. And my first idea was, you know what? I just look at the exact data. Screen width, screen height, and I go for there. Now here, this is from Google Data Studio, coming from Google Analytics. What do you see? Plenty of variance. So from a performance perspective, it's like, which one should I pick? Which one should I focus on? Do I take this one or do I take this one? Which can I merge? Can't I merge? So here again, just taking the screen, if you would just take the screen resolutions, that works. But again, you have just way too many different variants. And then if you zoom in on an object with on a screen's resolution with just 5%, you're just looking at 5% of the data. The other problem is screen dimensions. It does not help with resizing windows. On many large screens, you have two screens next to each other. You're not loading the big version, you're actually loading a smaller version. Or another issue is if some people hold their phone like this or like this, then you load a different version. You can also see that as resizing. And then on my website, I also have an enforced desktop. This is, so my web design, my website is responsive. Now, some of my users complained like, you know what, Tim, my tablet is very big and I actually prefer the full desktop version rather than the mobile version. So everybody has the option to turn on desktop or not. So how did I fix it? And it's actually easy to fix. So this is an example page of my website. And what you're looking at here is my website in the design 720 pixels. That's the width of the mid area. And then it has a large sidebar. So that's the name I gave. Now this is on a big screen. Suppose the website loads on a screen which is a little bit smaller. Yes, it's a different screen, but from a performance perspective, it's still the same version which is shipped. The same amount of images, the same dimension of images, the same thing. Next one, exactly the same. All these different variants on screen sizes. In the end, I ship the same version, 720 pixels large. Still the same. Still the same. Sorry, one click too much. And now here. At a certain point in time, what happens is when the screen is too small, suddenly there is not enough room for the large sidebar. The mid section is still the same as the previous one. And here I do a few changes. So for example, I have different advertisings and a few other things. So that's what I call 720 pixels small. If you make it even smaller, at a certain point, that's the tablet version, how I call it, the sidebar goes away, but it's still the same 720 pixels image I shipped earlier. It's only when it becomes smaller, at a certain point in time, I ship the 540 pixels version. So I use the picture element and then with different source sets. So with different sources. So the browser picks the right image to have a good quality. If I make it even smaller, at a certain point in time, I switch to the 360 pixels small version. So from all these different variants, in the end, I can simplify it to this. So I take the scroll width, because that defines which version is loaded. And basically, if the screen dimensions are bigger than 1080, then it's this version. 20, 30, 50, 60, I don't care, different versions. From a performance perspective, performance analysis perspective, it's the same version, it's exactly the same. And here, that's how I define, and it's only at 360 pixels that that's for the small variants. So you see 1, 2, 3, 4, 5. Key here is, do I have more CSS breakpoints? Yes. I have like between 360 and 540. At a certain point in time, I switch my font size a little bit. At a certain point in time, for example, when there's not enough space, I hide one of my additional menu items. Do I add them in here? No. Why not? Because in the end, it's still the same HTML, the same CSS, the same type of images. So I don't want to explode the amount of different versions, the different versions I have. So that brings me from all these different types to 5 design breakpoints. First thing is this 720 no version, which I spent a few hours trying to design and fix. What you see, it was a waste of time because almost nobody is using that. So should I focus from a performance perspective on that version? No. Let's first look at the others. If I then zoom in on mobile, as expected, the 360 pixels no version is bigger, but 720 small, that's people selecting the desktop version. If you would look at your RUM data and saying, why is my 95th percentile so slow? I just don't get it. Yeah, I get cellular connection, but still, it's way much more. That's because you don't ship the 360 pixels image, you're shipping the 720 pixels image. And remember, a bit earlier, I said there are almost no mobile devices with a 1x screen. So if you're unlucky and this is an iPad or like an iPhone, whatever, then you're shipping 720 pixels times 2, because it's 2 pixels. So you're shipping the 1440 pixels image. Is that slower? Likely yes. So that's a key thing to understand. Like if you look at your data, why is there such a big difference in RUM connection? You're shipping more bytes than needed, and sometimes some people actually even request the larger images. So how does that look in my RUM? Just as an example, this is now Impulse. But here you can, for example, see that I can validate what is my largest contentful paint, not for tablets, not for mobile, not for desktop. I look at the largest contentful paint for my different designs, because that can have a different impact. I can, for example, also look here at how many bytes do I ship for each version. Many of you have like a performance budget or know a performance budget. Oh, I should not ship more than the amount of bytes. But the amount of bytes, if you're shipping 2x images or 1x images, is a big difference. Why did I still zoom in here on mobile? Because I still assume that mobile has like a lower memory and is typically less powerful than desktop. So that's why I combine mobile and cellular. that's combining the two. That's for me a mobile user using the website under mobile conditions. And this is then the performance by design. So responsive RUM. Summary is the very simplistic desktop mobile device. Does not work in a responsive world where we ship different images, different screen resolutions, etc. So in order to fix it, it's actually very easy. First, add the connection. And so take into account the connection, take into account your image quality. And if you apply the image breakpoints technique, then the amount of variations is limited. And in order to take into account all the different screen sizes, large laptops, small laptops, big laptop, whatever, then look at the design breakpoints, because that tells you which variant you ship. And that will make the data analysis a lot easier, and you will find some interesting insights. So that brings me to the end of my talk. Thank you very much. And are there any questions? And before actually we go to the questions, because Sergey, I think we forgot to mention, because this is a smaller talk, and as we have 1 hour, after the Q&A of this part, I will actually talk about a second part, a shorter one. I will do a small demo of FRUSTRATIONindex, which is a different way to measure performance. But first, for the PS, so don't go away yet. So if are there any questions from a Q&A perspective, and I'm happy to take them.
Yeah, we do have a question. Whatever the designs is the impulse custom dimension in the slide that you showed.
So so in impulse terms, indeed, that's a custom dimension, and it's a custom dimension just reading a JavaScript variable, just like I do the same in Google Analytics. In Google Analytics, you can also assign a JavaScript variable to an additional dimension. So I don't know how it's done in other tools, but from an impulse perspective, indeed, it's a custom dimension.
Yeah. I actually have another question. Maybe a very weird one, but still. So you talked about reducing the cardinality of your data, right? Which is critical to real analysis. Otherwise, it's just like your brain would explode. But I also find that a lot of our tools make it hard to understand the data. It's basically a filter, and you just get the table of data. Do you know of any? Since now with this approach, you have kind of constrained the cardinality quite a bit. Is there any visualization or that could be helpful to understand this universe of devices, this responsive nightmare that we usually talk about?
Yes. So what I do, and I call that my performance matrix. I should have added a screenshot. In the end, when I look at the performance of my website, I have a matrix. So at the top, I have my design breakpoints, 720 pixels, 360 pixels. And in the, so that's the columns. And as the rows, I have my device pixel ratio. So then I can pick any, I can pick any metric I want, for example, largest contentful paint. And I can see, largest contentful paint on the 360 pixels design on the 2x is too big. And I can, for example, look at the amount of image bytes I ship to the 360 pixels dimension with 2x things. So I use a matrix with design breakpoints, DPR, and then typically a third one, either the connection, cellular, or just just the simple device type.
Mm-hmm.
Does that answer your question?
Okay. It does. I just wish there was like a way to dream about it in some 3D space or whatever. I don't know. Like to wrap the brain around this stuff is very hard. I find it like almost impossible. That's probably why we have only 3, just to make it easy.
Yeah, the thing is, if you're adding too many dimensions, then at a certain point in time, it becomes too complex to look at because you just have too many different boxes.
Okay, we have a few more messages in the chat. So Greg, for example, suggested histograms to maybe simplify things as well. And Alex Padelko is asking, why do you name it making RUM responsive? Do I understand it correctly that we're talking what information we want to have in RUM to analyze responsive design?
Correct. So for me, responsive design is adapting your website based on the screen size and the screen quality. So responsive images is shipping high resolution images to high resolution screens. Responsive design is about shipping under this one design, but then it adapts. And the simple RUM, just with a simple classification, desktop, mobile, tablet, in my view, does not correspond to, does not qualify enough for responsive. So in my view, the default RUM is not responsive. You need to add at least these two additional dimensions in order to make it responsive.
It's interesting because I think I understand where Alex is coming from as well. Similarly to, basically, I observed this problem in the industry that people, the word responsive, nobody is against responsive, but everybody understands what it means very differently. and I even seen it being perceived as related to actual speed. Like, oh, it's a very responsive website. Like, yeah. not as in like responsive as an engineer thinks what responsive means. So that might be like a vocabulary confusion. I actually find it that the word performance itself has similar confusion on its own. So yeah, words are hard, folks. I completely understand. Okay, we have another question from David. Out of curiosity, what system do you use to create images with different sizes and pixel ratios? Is that done dynamically?
Yeah, that's done dynamically. Yeah, so the positive thing, because I work at Akamai, I use the Akamai solution in order to do that in a fully automated way. But in theory, the same can be applied with any either if I would have done it custom made in my backend or used another cloud service, it would have worked as well. The key thing is dynamic, because I have more than 12 million different images on my website, and yeah, they are all auto-generated. They're all auto-generated. Does that answer your question, David or David?
And yes, he says yeah. By the way, yeah, remember that cache trick that you mentioned, right? Like edge cache. It's kind of like you need to be careful. So many images, you have a tail, and it's pretty long.
Yeah, yeah. I have some product pages which are viewed 2 times or 3 times a month. So yeah, I just for I have like 6 million page views a month. So around 30 to 35,000 scale modelers visit my website on a daily basis. It's not a huge website, but it's also not like a stupid small blog post. But yeah, long tail content and long tail content optimization is something I need to think about.
Yeah, I imagine that Razor Crest has a lot of views on it. I saw the top model today, right? Razor Crest.
Which one? The
Razor Crest.
Yeah, that's yeah. So I have extremes. A few products take up a large portion of the traffic, but then yeah, I have like a mid tail and a long tail, which is very long.
Another question. Luca is asking, since today some mobile connections are performing better than broadband ones, should we have a look also to other variables like throughput, TTFB, things like
that? Since today performing better than broadband, should we have a look also at other variables like throughput, time to first byte? Yeah, so especially now with 5G, the connection, yeah, that will make things even overlap even more, where you can have like a mobile phone with a better connection than somebody at home with a desktop on a cable. So that will make things more complex. On the other hand, although that just makes the connection type more special, you could then still say, you know what, I can then look at what is the performance of my mobile version, the 360 pixels on 2x, how many bytes do I ship? So many of these things are independent of the connection. And if you really want to fix the performance issues under bad conditions, then you can just zoom in, for example, using the networking API. You know what I want? For me, cellular is cellular connection with a 3G under 3G conditions. Time to first byte could be one way. The issue with time to first byte is that it depends on your page. So is it cached in the CDN? Is it dynamic? So if you would look, what I tend to look at in that case, just to have like a validation, is, for example, the TCP connection time or the SSL handshake time, because that's independent of the page you're looking at. So that's something sometimes what I use to just validate how fast or how slow is this connection actually. I use TCP connection or SSL handshake as a let's say a benchmark, just to validate, like, is it very, if the TCP connection is fast and the performance is bad, then I know my performance is a problem. If your TCP connection is slow and your performance is still very reasonable, then you know that the site still behaves well under bad network conditions. Don't know if that responds to your question. That was it was Luca, I think. Yeah, it moves up.
Yeah, I would want to say that I also found a funny trick is that if your static resources are served from the same domain, then you can gauge the impact on time to first byte from static resource versus the HTML page, and see that difference as well, and that will tell you like how much of it is a network question, how much of it is a server processing time.
Yeah, very, very, very valid point. Yes.
Lucas says yes. Rami is asking, in the age of CDNs, do you believe that all the complexity should happen at the edge, or it's developers' job to ship images in the right format, size, ratios, and so
on? Yeah, I work for a CDN, so my answer will be biased. But my thing is, like, if you need to do it in bulk and in a fully automated way, I'm very happy that my CDN can do it for me. On the other hand, in my view, one part is the resizing, because, to be honest, resizing images is pretty easy. When it becomes complex is when you take into account different formats like WebP, JPEG XR, JPEG 2000, AVIF. Then that adds another dimension to the amount of bytes you ship. So if you're happy with JPEG, then I would say it's rather easy potentially to do it image magic, resizing an image to multiple variants. That's not black magic. But once you start with serving WebP, doing other optimizations, perceptual quality, then typically I would say that a CDN solution, any CDN solution or any cloud service, is a better approach. Does that answer your question, Rami?
and by the way, ImageMagick has challenges with recompression. It's by itself not very good at compressing the images as well. So, yeah, we have a lot of talks on image optimization here. Actually, it's quite a challenging topic for sure. Yeah, Rami says yes. Okay. Okay, Alex is saying that maybe, like, when you say making RUM responsive, you meant making a RUM dashboard responsive, or working on mobile tablet.
Yeah, you can also read the title like that, but that was I hope you understood that was not the goal of my talk.
Yeah, Samar is saying, how do you handle 2x device pixel ratio with a slow connection? Do you have something related to adaptive serving in that case?
Yeah, that's a good question, and it's actually a talk I gave last year. It was data shaver strategies, and what in the end it's 2x images, high quality on a bad connection. It's not ideal, and some users actually in many browsers you have a data saver mode that there you have the user basically begging you, please don't ship too many bytes. So when I detect the data saver mode or a bad when I detect the data saver mode, I will, instead of serving the 2x version, I just serve the 1x version. So I basically downgrade the quality because people asked for it. Do I do it on a bad quality? It is perfectly possible. The reason I don't do it is because when the images are when the images are optimized and you don't over you're serving WebP's perceptual quality, then you reduce the problem a lot from sending too many bytes. And the issue of why I decided not to say like, oh, when there is a bad quality connection, the problem is, suppose you're like in the train and you have your website and you're expecting good quality, and then you just have like a small blimp and you temporarily have like bad quality. Do you, from an end user perspective, do you want to, for in my case, scale modeling, I want to, people want to see the good image. They don't like to see pixely pixels on the thing. The same for e-commerce. Is it better to ship a lower quality image which loads faster, but then where people can't say like, oh yeah, that product doesn't work, versus still shipping the higher resolution one while it's still take a little bit of time. So I'm not a big, although it's perfectly possible, I'm not a big fan of reducing the quality based on network conditions. So that's my personal opinion. Samar, I don't know if that responds to your question.
Mike is asking, yeah, he has got it. Mike is asking, what are the best breed tools for telemetry performance data to measure customer digital experience? I don't know if it's a plant or not. I'm just saying.
So on one hand, you have the pure marketing tools, Google Analytics, Adobe Analytics. That's more for marketing. If you're meaning with digital experience performance, then yeah, I would say there are a lot of RUM tools on the market. Yes, you have open source Boomerang, which some of the RUM tools, commercial RUM tools, are using. So that includes all the features like cumulative layout shift, time to interactive, all the new features. And then some of the RUM tools like Amples are built on top of the open source one. And there are a few others on the market. I would say it depends also on your requirements, depends on how many traffic you need, traffic you have. Do you want to do sampling or not? Those are all interesting discussions. But yeah, you have there are many tools on the market.
Yeah. Tim is modest. He cannot promote his company's product like that openly. It's good. Impulse is good. As a user, I can attest to that. So, generally, and you always need to look at more than just collection of data, but also dashboards, segmentation, all of those kind of things. And that's what makes a great RUM tool. Yeah, Mike is mentioning a few other tools like Dynatrace, Datadog.
So Sovasta is actually Sovasta was bought by Akamai 2 years ago. So Sovasta was behind open source Boomerang, and Sovasta had the product Amples, and so that's the product I use on my website.
Yeah, Just keep in mind to differentiate between RUM tools and user experience tools and APM tools, which mostly are about server. I'm not gonna name the names, but yeah.
Yeah, I for example use Datadog on my backend to monitor the backend, how many CPU I'm using, how many disks I have, where in my PHP code I'm slow. So that's more like the backend. And then on the front end, I use the RUM, which I already told.
Yeah. Okay, I think that's it on the questions. And team, if you can reach and show us the frustration index, which is another interesting topic.
While I switch, so the question: do you use WebP images on your website? Yes. Yes. So I serve WebP when WebP is actually better. So not only just blindly, sometimes JPEG is better. So there is an algorithm which serves WebP only when it's better. Let us quickly look at frustration index. So first, thank you for all the questions and still being there. That means you didn't fall asleep, or you fell asleep and you're still hanging around. That's also possible. So frustration index is something I introduced a year ago in a blog post on Performance Calendar, which Sergey also recommended. And what is frustration index? Frustration index solves a problem which I think till without frustration index it's very difficult to solve. So let's have a look. And it's an open source tool, and I'll switch afterwards to the link. So suppose your website load like this: blank, 2 seconds still blank, 3 seconds blank, 4 seconds blank, 5 seconds blank, 7 seconds, many seconds blank, and then suddenly everything appears. Is that good user experience? Everybody agrees no, right? So if you would look at users and you would look at their frustration, in the beginning they're still happy. At a certain point in time they're getting like a little bit annoyed, and at a certain point in time frustration starts building up. So the longer we need to wait, the bigger the frustration. I would say makes sense. Suppose this example. Is this better for the end user? I would say yes, because after 3 seconds you already show something on the screen. So something is happening, cool. And then you need to wait a little bit more, and then the next thing happens. So if you would look at the frustration levels, is I'm not frustrated, and frustration starts building up, and then, oh, something happened, I'm, let's say, happy again. And then the longer you wait, frustration would start building up a little bit more. And in this case, I would say everything is still in the green zone. Now, here is the problem. Everything we do in the web performance world is always about, if you have a value and you make it better, it's a good thing. Like if you make first paint faster, cool. If you make largest content fill page faster, cool. So it always is about, if you make a value better, it should be better for the user experience. Now, I work at Akamai since 7 years, and I've seen a lot where we make, sometimes it happens, you make performance better, you look at the data, and then there are like there's no business impact. And that's like, how is that possible? And normally better performance, better business impact, we made it something a lot faster, and no business impact or lower than expected. So let's have a look here. And that's a big problem. This example, this one, purely by the numbers, this one is better. Why? Because first paint happens a lot sooner than here. So this is great for user experience. But once you show something on the screen, what happens now? Now the user needs to wait 4 seconds before something happens. So from a frustration perspective is, before the user got even frustrated, he showed something on the screen. Awesome. And then you have to wait longer before the next thing happens. Think about skeleton designs, where you see like a very early something on the screen. That can be a great user experience. If that happens super fast, but next you need to wait 10 seconds, then you're still unhappy. So what is frustration index doing? Instead of looking at individual timers, like first paint, time to interactive, they are all valid. Frustration index looks at the difference between timers. So what is the difference between time to first byte and first paint? What is the difference between first paint and largest contentful paint? What is the difference between largest contentful paint and the full page load or time to interactive? And the difference defines the potential level of frustration. And based on these differences, frustration index generates a score. Lower is good, higher is bad. So in this case, you would actually see, so although first paint is faster, from a frustration perspective, this still has a worse score. While because the gap between two timers is too big. So this is not just about, oh, we need to make things faster, faster, faster. It's also about if I make one thing faster and the next big step does not change, then you might actually increase performance. And how does the tool work? Let me just switch. So if you go to, do I see it? No, that's not, frustration index, there it is. So what do? If you take, for example, a web page test result.
You are sharing the tab with the presentation alone. So you switch the tab on your end, but it didn't switch the presentation.
Okay, so thank you for that. So let me do desktop 1, share. Can you now see a web page test page?
Yep.
Cool. So if you go to FRUSTRATIONindex.com, free, no advertising, and you just copy paste a web page test result, and you say calculate the index, you get a few things. First, it will give you what is the likelihood of frustration. So that's very good. And you also see, not only get a score, but you also see where should I focus? Where is the gap too big? Now, this is an example which is too fast. So let's take another scale modeling website, which is a little bit slower. Still a good website. So if this person ever sees this this recording, I still love that website, although it's a bit fast. So here you see, oh, the score is worse. So let's look where things go wrong. Although the time to first byte is pretty okay, 448 milliseconds, let's not complain about that. That's good. That's why do I look at time to first byte? Because that's typically when the user sees the title. So even if you don't see anything on the screen and you already see the title of the website, you already got feedback something is happening. First contentful paint. So although the time to first byte was good, first contentful paint was more than 2 seconds. So as you can see, frustration starts gently building up. Then we look at time to visually ready or the speed index, depending on which tool you're using. And then either time to interactive or page load. Repeat view. And then here you can see like, oh, so if I would focus on performance, it's mainly this. So should I fix the time to first byte? Not really. If I fix time to first bytes and not visually ready, the amount of frustration will still be the same. The issue is that the gap between first contentful paint and, let's take this one, this gap between first contentful paint and visually ready is too big. So I would rather focus on that. So very easy to do. The formula is actually also, how to do that is also explained here. So it's a very simple piece of JavaScript. I use this as well. I calculate the frustration index in the browser. And I also send that to my RUM. Actually, I think I even have it open. So here you see the frustration index. Here I did some tuning. So that's the 95th percentile, a frustration index of 32. For the worst experience is still okay. Was I happy about it? No. So I decided to tune it. So that was the short version of frustration index. So is it a new metric? Is it a new timer? No, we're using existing timers, but it takes a different angle. Instead of just looking at time to first paint and trying to do that, we look at the gaps, and the gaps define the frustration level. Make sense? Any questions about this?
Yeah, this is amazing. We all try to make sense of the multitude of metrics that we have to track, and this is one interesting approach to that. Yeah, I read the article, by the way. Like it's awesome. It's awesome.
Yeah, and I think the positive thing is because it's like a simple. It's not like a simple. It's a simple number, so you can use it internally to the business. Everybody understands like, oh yeah, 40 is worse than 32, and if you go from 40 to 35, it's like an improvement. So without being a performance expert, you can still use it. While the performance team still it's still a meaningful number, and not just like a let's say a very simplistic A to F score. So yeah, that's it.
Yeah. It's worth saying that that there are other similar approaches, not similar, different approaches with a similar goal, like happiness index, for example, right?
Which one?
The happiness index from Speed Curve. You know, they do it very differently, but this particular approach is
but the difference is so happiness index. Yes, you have the difference is so you have a few indexes which take a few numbers. The thing there is as well is you're looking at multiple numbers and you create a score, just like the page speed insights. But there also everything is like if you make one of the numbers better, your score will always be better. So if you make one of the elements of happiness score, if you make it better, your score will always be better. Here, it's really about, it's not because you can actually, if you make something better, it's possible that you increase the gap and that your frustration index will actually lower. So I think that's a key difference with all the other things. It's, yes, you have many indexes, but this one is really about looking at the gaps, and it doesn't, you can make something faster but still make the frustration index worse.
Yeah, it's similar to what's the web page test speed index, right? Similar to speed index approach to some degree, right? Like the more smooth the load is, the better. Although speed index, again, it's always the sooner the better, right? But it's about progression of page load rather than just absolute numbers.
Yeah, and don't get me wrong, because for example, in if you take web page test results, I use the speed index as one of the metrics to calculate. So I'm a big fan of speed index. I'm a big fan of all the other things, but it's just about looking at the difference rather than just looking at the individual numbers.
Yeah, awesome.
Thank you for the feedback, Jennifer, Samar, Michael. Thank you. Any additional questions about this?
And sorry, folks, we didn't really plan it. It was like last moment request from me to include that, and Tim suggested it. But I was like, yeah, that would be awesome. Okay. Perfect. And I know some of us definitely appreciated this part too. I know people in the audience who appreciated this part as much. Okay, I think we don't have any more questions. Thank you very much, Tim. It was really, really insightful, both parts. Like responsiveness and frustration are both a big part of our world, performance world. So no surprise there. Thank you very much, everybody, for coming. Thank you for attending. I hope you can all join us for Meet for Speed next week and for Samar's presentation next month. Team, where should people find your work? Where should they follow you? What's the best way?
Yeah, both on Twitter, so @TimVerreke. It's and I tweet about everything related to web performance. I don't tweet about politics. I don't tweet about sports. I tweet about general. Sometimes, yes, there is something related to Akamai, but it's not a marketing. It's not a marketing thing. So feel free to follow you. And if you tweet about web performance, then I will likely follow you back. And you can also follow me on LinkedIn if you want, or connect on LinkedIn. Thank you very much, everybody. Thank you for joining. Thank you for all the questions. I loved it.
Thank you.
Have a nice day. Bye-bye.
Bye, folks.